Hi, welcome to the experiment 2 of the complexometric titration for the determination of calcium in drinking water. For this specific experiment, you'll need several laboratory apparatus: the burette, pipette and its rubber bulb, measuring cylinder, conical and volumetric flask, filter funnel, beakers, spatula and glass dropper. As for the chemicals, you're going to need areochrome black tea indicator, your water sample, buffer solution of pH 10, diluted hydrochloric acid of 20%, sodium hydroxide, ethylene diamine tetraacetic acid or EDTA for short, calcium carbonate, as well as an analytical weighing balance as the instrument. Firstly, you need to weigh about 0.25 gram of calcium carbonate using the analytical weighing balance. Make sure that the balance is on a sturdy and stable surface, and do not forget to close the glass doors on both sides of the balance. Next, press the tare button until you get the displayed value of 0. This is important in order to avoid any erroneous measurement. Then, using a clean spatula, scoop a small amount of calcium carbonate and cautiously transfer it into the beaker until you get about 0.25 gram. Remember, please do not return the excess chemical into its original container, as this may cause contamination. Should you have excess calcium carbonate on the spatula or any other chemicals for that matter, you may simply discard it in an appropriate and labeled waste container. Next, weigh about 1 gram of EDTA and 0.025 gram of magnesium chloride hexahydrate. For preparing the calcium carbonate solution, you'll need the 0.25 gram of calcium carbonate that you had just weighed and diluted hydrochloric acid, a small filter funnel, and a clean 250 ml of volumetric flask. Next, Add dropwise of diluted hydrochloric acid into the beaker containing the calcium carbonate. Be sure to cautiously stir the mixture in order to dissolve the solid completely until a colorless solution can be observed. Make sure that you have completely dissolved all the solid samples, including the ones at the wall of the beaker. Then, using a clean filter funnel, transfer the solution into the volumetric flask. Make sure that you rinse the beaker for at least 3 times to ensure that all of the solution is transferred into the flask. After that, you may further dilute the solution with distilled water up until it almost reaches the calibration mark, preferably about 3/4 of the flask. Using a dropper, slowly add more distilled water until it reaches the calibration mark. Now remember that the meniscus should be viewed at eye level. If too much of the distilled water is added, the solution must be discarded and a new solution should be prepared from the first step of this procedure. Then, firmly cap and mix the solution thoroughly. And lastly, make sure that you label the volumetric flask accordingly. Now, for preparing the disodium EDTA dihydrate solution, you'll need about 1 gram of EDTA, 0.025 gram of magnesium chloride hexahydrate, 4 pellets of sodium hydroxide, filter funnel, glass dropper, and of course the volumetric flask. Using an appropriate amount of distilled water, dissolve all of the weighed chemicals and transfer all of them into the volumetric flask. Make sure that the all weighed chemicals have been completely dissolved. As usual, upon transferring the chemicals, rinse the individual beakers with distilled water and transfer it into the flask. Then, cap and mix the solution thoroughly. Lastly, transfer the sodium hydroxide solution into the beaker and don't forget to rinse the beaker. Again, cap and mix the solution thoroughly. Similar to the previous solution preparation, further dilute the solution with distilled water up until it almost reaches the mark. Then, you may use a dropper to slowly add more distilled water until it reaches the calibration mark. Make sure to label the flask accordingly. For the second part of the experiment, it will involve the standardization of the EDTA solution using the titration technique with known amount of calcium carbonate solution that you had just prepared earlier. Here, we need about 3 250 ml of conical flasks, 200 ml of beakers, prepared calcium carbonate and disodium EDTA dihydrate solutions, aerochrome black tea indicator, burette clamp to the retort stand, filter funnel, and 25 ml of pipette and its rubber bulb. Firstly, you need to rinse the burette with the disodium EDTA dihydrate solution, preferably about 3 times, and discard the solution in the collection beaker. Once done, fill up the burette with the solution and do not forget to take the initial reading. Then, rinse the pipette with the calcium carbonate solution and pipe out an accurate amount of 25 ml of the solution into each of the conical flasks. Using a measuring cylinder, add about 1 ml of buffer solution of pH 10 into each of the flasks. And add about 2 to 3 drops of Aerochrome black tea indicator. Swirl the flask gently. Place the flask beneath the tip of the burette, making sure that the tip does not touch the walls of the flask. Slowly open the stopcock so that the titrant drips out of the burette drop by drop. You may gently swirl the flask while you're at it. Once you notice a permanent color change from red to blue, close the stopcock, as this means that you have reached your end point. Be sure to take note of the final reading, and do not forget to repeat this step for the remaining 2 flasks, and make sure to fill up the burette again before you begin titrating. Finally, the last part of the experiment, you'll need a 10 ml pipette and its bulb, 200 ml of beakers, your water sample, 3 conical flasks, aerochrome black tea indicator, buffer solution of pH 10, and a measuring cylinder. Firstly, transfer an appropriate amount of your water sample into a clean beaker and pipette out about 10 ml of the sample and subsequently transfer it into the conical flask individually. Next, add approximately 1 ml of buffer solution and a few drops of aerochrome black tea indicator into each of the flasks. Then you may proceed with the titration process using the disodium EDTA dihydrate solution prepared earlier until you observe a color change of red to blue. Be sure to take the initial and final readings. Similarly, repeat this step of titration for the remaining 2 flasks. and you're done. Thank you.